Myself, Jadhav. I am from HM College, Karad. In our previous lecture, we are seeing the formulas of integration. Today, we are going to discuss the rules of the integration. Yes, there are three rules of the integration. First rule is, if f and g are real value integrable functions of x, then integration of f of x plus g of x dx is equal to integration of f of x dx plus integration of g of x dx. Okay, it means that if inside the integration there is addition, so we separate the integral symbol with dx to both the terms. Okay, second is, if inside the integration there is subtraction, look at it. If inside the integration there is subtraction, then we can separate integration sign to both the terms. Okay, that is integration of f of x minus g of x dx is equal to integration of f of x dx minus integration of g of x dx. Okay, and third rule is integration of k into f of x dx is equal to k into integration of f of x dx, where k is a constant. It means that if inside the integration there is any constant term, you can take it outside the integration symbol. Okay, so we have proved these theorems. First theorem is, we prove this theorem. First theorem: if f and g are real valued integrable functions of x, then we prove integration of f of x plus g of x dx is equal to integration of f of x dx plus g of x dx. ओके, हे थेरम आपण जेव्हा प्रूव्ह करणार आहे तेव्हा आपण डेरिव्हेटिव्हच्या रूल्सचा उपयोग करणार आहोत. ओके, तर प्रूफ आपण याचं पाहणार आहोत. लेट integration of f of x dx is equal to, okay, integration of f of x dx is equal to phi 1 of x plus constant of integration c1, and integration of g of x dx is equal to phi 2 of x plus c. Okay, it is the definition of integration. We are moving to definition of derivative. Integration of f of x dx is phi 1 of x plus c1. It means that d dx of phi 1 x plus c1 is equal to f of x. Okay, and from second, integration of g of x dx is equal to phi 2x plus c2. It implies that d dx of phi 2x plus c2 is equal to g of x. Yes, we have learned the definitions of integrations and derivatives from this. Yes, it's our equation number, suppose first, it's our equation number second, it's our equation number third, and it's our equation number fourth. Consider we add equation third and equation fourth. So we get ddx of 5-1x plus c1 plus ddx of 5-2x plus c2 is equal to, we add LHS terms. Now we add RHS terms, is equal to what? F of x plus g of x. Okay, here derivative is separate to both the terms. Now I can take ddx common. So ddx of 5-1x plus c1 plus 5-2x plus c2 is equal to f of x plus g of x. Okay, now by definition of integration, if derivative of f of x is g of x, consider this term as f of x and this term as g of x. If derivative of f of x is g of x, then integration of g of x is f of x. Okay, so therefore by definition of integration, integration of f of x plus g of x with respect to x is equal to, yes, here is 5-1x plus c1 plus 5-2x plus c2, which is equal to, from equation first, 5-1x plus c1 is nothing but integration of f of x dx. Integration of f of x dx plus 5-2x plus c2. From equation second, it is g of x dx. Integration of g of x dx. Okay, thus integration of f of x plus g of x dx is equal to integration of f of x dx plus g of x dx. Hence the proof. Okay, hence the proof. It states that if inside the integration there is addition, separate the integration symbol also dx to both the terms. Okay, now we are proving our second theorem or second rule, which is, second rule is, if f and g are integrable functions of x, then prove that integration of f of x minus g of x dx, okay, is equal to integration of f of x dx minus integration of its g of x dx. Okay, it is much similar to our previous theorem. If f and g are integrable functions of x, then integration of f of x plus g of x dx is equal to integration of f of x dx plus g of x dx. Okay, it is similar to that theorem. So proof of the theorem is same as previous theorem. Starting with proof, let integration of f of x dx is equal to 5-1x plus c1. It implies that ddx of 5-1 of x plus c1 is equal to f of x by definition of integration. Okay, and integration of g of x dx is equal to 5-2x plus c2. It implies that ddx of 5-2x plus c2 is equal to g of x dx. The main change is consider subtraction of equation number third and equation number 4. Means ddx of 5-1x plus c1 minus ddx of 5-2x plus c2, which is equal to, yes, subtract their LHS. Now on RHS, subtract their RHS. Means f of x minus g of x. Okay, taking ddx symbol common, so it looks like, yes, ddx of 5-1x plus c1 minus 5-2x plus c2 is equal to, what is here, f of x minus g of x. Again, consider the term as f of x. So d dx of f of x is equal to, consider that term as g of x. d dx of f of x is equal to g of x. So integration of g of x dx, that is integration of f of x minus g of x dx, is equal to that term 5(1)x plus c1 minus 5(2)x plus c2. Okay, from equation first and second, 5(1)x plus c1 is nothing but integration of f of x dx. Okay, integration of f of x dx, and here is minus sign. 5(2)x plus c2 is nothing but integration of g of x dx. Okay, thus we proved integration of f of x minus g of x dx is equal to integration of f of x dx minus integration of g of x dx. Okay, if inside the derivative there is addition, separate the derivative. Like that, if inside the integration there is addition, separate the integration sign with the dx. Okay, if inside the derivative there is subtraction, separate integration sign, separate integration sign with the dx. Okay, next we prove our third rule or third theorem. If f is integrable function of x, if f is integrable function of x, then prove that integration of k into f of x dx is equal to, take it outside the integration, k into integration of f of x dx. Okay, now look at it. To prove this result, we use rules of derivative. Okay, for that we consider the term of integration of f of x dx as phi of x. Consider integration of f of x dx is phi of x plus c1. This implies that, yes, from definition of integration, if integration of f of x is phi of x plus c1, then derivative of phi of x plus c1 is f of x. So d dx of phi of x plus c1 or its c is equal to f of x. Okay, now multiply both sides by k. So k into d dx of phi of x plus c1 is equal to, here is k into f of x. Okay, now if there is constant in derivative, we can take it outside the derivative. Now I can take k inside the derivative symbol. Therefore, d dx of k into phi of x plus c1 is equal to k into f of x. Okay, look at it. Consider this term as f of x and this term as g of x. Here is derivative of f of x is g of x. If derivative of f of x is g of x, then integration of g of x, integration of that term is k into phi of x plus c1. Means, therefore, integration of k into f of x dx is equal to k into phi of x plus c1. Okay, but from equation first, here is our equation number first, integration of f of x dx is equal to phi of x plus c1. From equation first, phi of x plus c1 is what? Integration of f of x dx. So it becomes k into integration of f of x dx. Okay, hence integration of k into f of x dx is equal to k into integration of f of x dx. Hence the proved. Okay, the rule says that if there is any constant inside the integration, then we can take that constant outside the integration. Okay, so we have learned three rules. Which rules? First one is if integration of f of x plus g of x dx is equal to integration of f of x plus g of x dx is equal to integration of f of x dx plus integration of g of x dx. Second rule is what? Integration of f of x minus g of x dx is equal to integration of f of x dx minus integration of g of x dx. And third rule is integration of k into f of x dx is equal to k into integration of f of x dx. Okay. So remember these three rules. Okay. Now we are seeing some examples on that rules. Okay. Here is the first example in evaluate integration x cube plus 3 raised to x dx. Okay. First, identifying the example is of integration. Okay, its symbol is for integration. So the name of the chapter is integration, and integration starts from I. So consider or let that integration be I. Let I is equal to integration of x cube plus 3 raised to x dx. Inside the integration, there is addition. Okay, and today we are seeing that if inside the integration there is addition, then separate integration sign with the dx. So separate integration sign means integration of x cube dx plus integration of 3 raised to x dx. Okay, we know that integration of x raised to n dx is equal to what? Integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1 plus constant of integration c, where n is not equal to minus 1. Here integration of x cube is there. Okay, so add power by 1 and divide by the same power. So here power is 3, it becomes x raised to 3 plus 1. 3 plus 1 is what? 4 divided by 4. Okay, plus now integration of 3 raised to x. We know that integration of a raised to x, here 3 is constant. 3 is constant, it means that 3 is base is constant. Okay, here base is constant, base is a, and power is variable. So using the formula for integration, a raised to x dx is equal to, yes, integration of a raised to x dx is equal to a raised to x divided by log a plus constant of integration c. So integration of 3 raised to x dx is 3 raised to x divided by log 3 plus, here is x raised to 4 divided by 4 plus c1 plus 3 raised to x divided by log 3 plus c2, and c1 plus c2 is again a constant, so that's why I am writing only one time, that is c. It's our answer of the question, integration of, find the integration of x cube plus 3 raised to x dx. Okay, now we are solving another examples of integration. Okay, second example is evaluate integration of x cube plus x square minus x plus 1 dx. Okay, first denote the given integration by I. So let solution of that example is let I is equal to integration of x cube plus x square minus x plus 1 dx. Okay, now look at here. Inside the integration there is addition, there is subtraction, here is again addition. If inside the derivative there inside the integration there is addition, subtraction, we separate the integration sign with dx. Okay, so it becomes integration of x cube dx plus integration of x square dx minus integration of x dx, separating integration sign with dx. Okay, plus integration of 1 dx. Okay, you have learned that integration of x raised to n dx is equal to what? Integration of x raised to n is x raised to n plus 1 divided by n plus 1 plus constant of integration c. Okay, here x cube is there, base is x, power is base is variable, power is constant. Okay, so we use formula for x raised to n dx. Okay, next also we have learned that integration of 1 dx is x plus c. Okay, so solving integration of x cube dx. Integration of x cube dx is add power by 1, means x raised to 3 plus 1. X raised to 3 plus 1 is 4 and divide by the same power 4 plus here is again integration of x raised to 2, add power by 1, so x raised to 2 plus 1, that is 3, divide by the same power 3 minus, here power is not given, so power is what? X, base is variable x and power is constant, so we use integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1 plus c, add power by 1 and divide by same power. So integration of x raised to 1 is x raised to 2 divided by 2 plus integration of 1. We know the integration of 1, it's x plus I can write the constant of integration c. So it is the solution of the given question. Evaluate integration of x cube plus x square minus x plus 1 dx. Okay, next we are solving another example on the integration. Okay, here third example of integration. Evaluate integration of x square into 1 minus x square into 1 minus 2 divided by x bracket square dx. Okay, first it is example on integration. So denote the given example of integration by I. Let I is equal to integration of x square into it's 1 minus 2 divided by x bracket square dx. We know that a square into b square. Yes, a square into b square is nothing but a into b bracket square. Here is x square into 1 minus 2 upon x bracket square. I can write this as integration of x into 1 minus 2 divided by x whole bracket square dx. Okay, now multiply by x. So x into 1 is x minus x into 2 by x. X into 2 by x, x get cancelled. What's remaining here? 2. X minus 2 bracket square. Now we know that a minus b bracket square. What is the formula for a minus b bracket square? A minus b bracket square is equal to a square minus 2ab plus b square. Using that formula, integration becomes integration of square of the first term x square minus product of this term and double it 2 into x minus 2x double of it minus 4x plus square of the second term, it's 4 dx. Now inside the integration there is what? Subtraction and addition. Separate integration symbol. So integration of x square dx minus integration of 4x dx plus integration of 4 dx. Okay, now what happened here? 4 is constant. Here 4 is constant. Therefore I is equal to 4 is constant. If inside the integration there is constant, take outside the integration sign. So it becomes integration of x square dx minus, here 4 is constant, integration of x dx plus, again here 4 is constant, integration of 1 dx. Okay, now integration of x square dx, we know the formula for integration of x raised to n dx. Add power by 1 and divide by the same power, that is x raised to n plus 1 divided by n plus 1. So add power by 1, here power is 2, add 1, 2 plus 1, 3. So it becomes x raised to 3 divided by same power, 3. Okay, minus 4 is constant as it is into integration of x. Here power is not given. What is the power? It's 1. Integration of x raised to 1, add power by 1. So it becomes x raised to 2 divided by same power, 2. Plus 4 is constant. Integration of 1 is x plus constant of integration c. On simplification, it's x cube divided by 3 as it is, minus 2 2s are 4, so 2x square plus 4x plus c. This is the answer of given example. Integration of x square into 1 minus 2 divided by x bracket square dx. Okay, next example, we solve the next example. Okay, so question is evaluate integration of 3 sec square x, integration of 3 sec square x minus 4 divided by x, 4 divided by x plus 1 upon x root x plus minus 7 dx. Okay, so we have to evaluate this integration. Since the example of is on the integration, so we denote the given integral by I. So let I is equal to integration of 3 sec square x minus 4 divided by x plus 1 upon x root x minus 7 dx. Okay, here inside the integration there is subtraction, addition, subtraction. So we separate integral sign. So it becomes integral of 3 sec square x dx. Okay, we separate integral sign with the dx symbol. Remember it. Minus integration of 4 divided by x dx plus integral of here x root x. The power of x is 1. Okay, and the power of another x is half. So x raised to 1 into x raised to half, it becomes x raised to 1 plus half. A raised to m into a raised to n, a raised to m plus n. So 1 plus half is nothing but 2 into 1, 2 plus 1, 3 by 2. So I can write this as 1 upon x raised to 3 by 2 dx minus integration of 7 dx. Okay, now look at here. Here 3 is constant, here 4 is constant, here 7 is constant. If inside the integration there is constant, take constant outside the integration symbol. So taking 3 outside the integration symbol, 3 into integration of sec square x. Okay, minus 4 into integration of 1 upon x dx plus integration of here 1 upon x raised to 3 by 2 is there, but there is no formula for 1 upon x raised to 3 by 2 or 1 upon x raised to power something. The formula is for x raised to n, integration of x raised to n. So we are writing the power x raised to 3 by 2 as x raised to minus 3 by 2. By law of indices, a raised to minus m is nothing but 1 upon a raised to m. Okay. Minus 7 constant integration of 1 dx. Okay. Which is equal to 3 into integration of sec square x. Okay, integration of sec square x is what? Whose derivative is sec square x? The derivative of tan x is sec square x. So integration of sec square x is tan x minus 4 constant as it is. Integration of 1 upon x. Integration of 1 upon x is, yes, whose derivative is 1 upon x? The derivative of log x is 1 upon x. So integration of 1 upon x is log x. But we don't know x is positive or negative. That's why we put modulus sign here, because logarithm of positive numbers are defined. Okay? Plus, yes, integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus constant of integration c. So it becomes, yes, x raised to minus 3 by 2 plus 1 divided by minus 3 by 2 plus 1 minus 7 into integration of 1 is what? X plus constant of integration c. On simplification, it's I is equal to 3 into tan x as it is, minus 4 into log of mod x as it is, plus on simplification minus 3 by 2 plus 1 minus 3 plus 2 divided by 2 minus 3 plus 2 minus 1 divided by 2. So it x raised to minus half divided by minus half minus 7 into x plus constant of integration c. After simplification, next step is 3 into tan x minus 4 into log of mod x plus minus becomes minus, and division is nothing but reverse process of multiplication. So 2 into x raised to minus half. This can be written as 2 into x raised to minus half. X raised to minus half can be written as 1 upon x raised to half minus 7 into x plus c, which is equal to 3 tan x minus 4 log of mod x minus 2 divided by, yes, x raised to half is root x minus 7 into x plus constant of integration c. It is the answer of given question. Okay, so today we have learned the rules of the integration. Okay, and some examples on the rules of the integration. I hope all the rules of the integrations are understood. Okay.